Hello, I'm Krzysztof Szymanski, and this is the momentum-based 3D platformer project that I've made for the independent project. So we start off with a title screen. Before I start the game, I'm just going to show off the menu. It's a very simple menu, but it can adjust full screen and the VSync. And this is all loaded from a save file that I'll show off later. But if we start the game, this is what the game looks like, and it's the idea of it is that it makes use of a already existing physics engine, and I've built levels around the physics engine um, to make unique levels. The game's running a bit slowly because I'm recording. Well, it's a bit choppy because I'm recording. So say for example, there's two pathways here. There's one with um, a loop, and you can see this ledge up here I can't get up to normally, but there is this path this way where if I run on top of it to try avoid the level hazard, I could run across the wall to make it to the other side, and I could only have done that by running. If I had stopped running, then I would have fallen into the hazard. So if I'm running on it, and then I stop, I drop, and then I can't, and then I take damage. But then if I wanted to go a different way, so say there was this way as a shortcut in the level, I can't reach it normally, but the way I can approach it is with this loop. I can, if I just keep, and then I manage to jump on time, that's how I can make that ledge. And if I just ran without jumping through the loop, if I didn't jump, I don't make it in time, so I also have to jump. So it makes use of a skillful sort of level design, where if you want to take shortcuts like that, you have to manipulate the level design and the physics. But I think that there should always be an easier path that you can go through, so to make it more accessible. That's sort of my design philosophy behind the level design. And I'll show off the second level that I made as well. This is just one of them, but we've got enemies here that are chasing me, and I take damage if they hit me. But then if I jump on top of them, they disappear. And I've got these gold collectibles. When I run into them, they heal me for a little bit. These gold collectibles are throughout the levels, and the levels have an open level design, so I can explore the levels if I want to for this health if my health is quite low. And the enemies have follow a state machine. So right now they're wandering around in the level, but then when I approach them, they start chasing me, and it's independent for each enemy. So in terms of each enemy has like different values. So say these ones here have quite a large radius of being detected, and they're also quite fast. But then if I go to one that's over here, say, when I jump up that spring, this one is a lot slower because it's on a smaller platform. So I thought it would make it um, make it more fair in because this is on a smaller platform. And then now, finishing the first level is taking me to the second level with the timer being reset and the health being reset as well, but the lives are staying the same. Um, so yeah, sort of level design is that you might have some secrets, like for example, you turn around and here you can actually go in for some more of the collectibles to collect. Um, but then if you go through the game, I think the camera is just a bit slow because I'm recording. But that was also tricky. If I fall off the level, I lose a life. So you see, because I built up enough speed, I was able to jump far enough to reach this platform. But if I didn't reach it, and this platform, I can go to this shortcut where I jump, and then the fan shoots me across to this part of the level, which I can jump up. And if I so that's a way you can use. So I built the fan objects to sort of propel, uh, to sort of shoot the player, and then if the player can sort of adjust their control right, they're able to run up that ramp, which they wouldn't be able to do normally, or at least they wouldn't be able to do normally very easily if I try it. Yeah. So if I try again, yeah, it doesn't. It's quite because it's very steep. But this takes us to the editor, the Unity editor. I'm just going to showcase that these levels were mostly made in Blender. So if I open up Blender, this is sort of so this is this is an example of how I made a full level in Blender. But usually, what I did, so for example, for the other level, it was mainly just separate components. So if I get up to say, for example, the curve platform that was over the lava, I made um, as separately, and then just sort of added onto it, and it was made with so there was the shape. So I made a curve um, that the shape kind of follows, and then with the array, I can sort of extend it. So I just make, so if I just go to one, I just made this one shape. Um, you can see, so just sort of like a barrier and like the beginning of a path. But then if I do that, I basically extend it to follow the curve, and the curve has its values of like what's facing up, and it's got different points as well. So it's how I'm able to shape a lot of these paths. It's with this sort of with these modifiers that's really helped me actually. I also made things like this simple goalpost just with like a cylinder and playing. And I made this separate. This was this zigzag sort of path. That was this part you can't actually see in the game because it goes through the wall. But then it was just easier to have it as one object instead of making like 1, 2, 3, 4, 5, so on. Just have it as one. This is a loop object I made as part of the open level. It's I basically just took a cylinder and reshaped it to sort of look like this, and I added a solidifier to make it more solid, and I manually sort of manipulated the vertices and such. And the last thing I just wanted to quickly show off was the fan. It's just a couple of examples of some objects I made, but it's um quite simple. These are just some like existing cylinders that I sort of squished and up, and this was a circle, and just to make a shape is like separate, so that I can in Unity I can animate it, which I'll show you. So a lot of the scripts from are from the engine that I reused already, so called Hedge Physics, which has scripts for some objects and some players already, but a lot of them I did add to. So, for example, for base physics, I sort of used this as also like the player class, because it pretty much was. So I added like health variable, lives, the animator, and also the display for the UI. And obviously, when they start, they always start with 100 health. Um, and they lose a life as well. And it's also where uh, I'll show an example of when the game saves into a save file, and also loads from the save file. So say you've got these two. So I've made it. If I just sorry go up to the top. So I made it inherit the interface for data persistence, and these two are what allows it to communicate through the interface. So obviously load data with the game data is essentially data from the file. So it makes it so the lives is the same when you load it, and then obviously when you save it, it basically does the opposite, where one of the lives is what's saved in the reference of the game data. Um, so if I open, so all everything to do with like the saving files, I did write under like data folder. So I can show off that yeah, this was the this is just a simple interface between, and then the actual data persistence manager makes use of the uh, serialized field that Unity sort of has, and so usually whenever it needs the data from the file, it loads, and then if it doesn't exist, we'll go into it will just make a new file with some default values that we can see from another class, the game data. So this is essentially like create a new game data if one doesn't exist, uh, which three lives, and then it just sets all the high score times to like 99.00, so like 99 minutes, basically, and um, this just creates a list of basically every single object uh, that inherits the um, data interface data persistence, so that it can run a for loop through the list to run the function for that, or the method for that object, or for that class, if that makes sense. So another thing I'll show off is the UI, because I did write most of the UI. I didn't use my own font. The font is reused, but I thought it was quite a nice looking font, instead of just the basic one that Unity offers. So if I go to the timer, this is a big part of actually. So the timer that's displayed. So if I run the game quick, obviously the timer that's displayed is a active timer that resets every time the player dies or the next level is loaded. So this level is complete. So if we quickly, so it's got a separate best time for um, that when the game loads, it loads into these variables, and it's got the actual count of each like minute, second. It was because so that I could get it just to display in like three different sections. So that's the way I did it. Uh, that's the actual. So this is the value, and then this is the game object on Unity. So this is for it to actually be displayed. So it's like you get the text of the object, game object, and then you set it to the actual value, the variable. And I had those two separate instead of. So obviously when it starts, everything starts at 0. Uh, and then when it loads the game, if the level is the open, load the best level time. If the level is linear, but load the best linear time. And then when it saves, if the player's health is greater than 0, so if it's not, if the player, sorry, if the level is loaded not because the player died, and because um, they actually beat the level. So if they have health more than 0, then basically check if the time is better than the old time, and then if it is, then you save it. If not, then you don't save it because it's not a high score then. Uh, and then this is just to update the actual uh, user interface, the actual display on in this format. So it's quite uh, it looks a bit long, but it's not too. It's just, and basically everything's done twice to sort of give the text that sort of casting shadow effect, because I think it looks quite nice, and also it makes it sort of pop out from the game itself like all the time. And obviously when it on trigger event, so when it hits the goalpost, that everything goes back to 0. Uh, so if I go to the main menu scene, and then I have the options screen as part of the same scene. It's just disabled when it starts, but these are sort of the default level times, and they're actually what the so if we press play now, it should display, yeah, so it displays the values of the save file, which if I can open, so if I get the actual .json file which we can read uh and play the game. So if we remember, say open level time, it's 0:31:26, and then we go see 00:31:26. Um, just as an example of that working, and then if we show off the code for that with options menu, um, so yeah, it's a similar sort of structure as the timer actually. So they could be displayed in the same sort of format, but Um, yeah, I've also got the graphic settings here. The graphic settings were quite quick to implement. That's kind of why I did them. Because this is pretty much it. Um, for yeah, yeah, at least like for the apply graphics, this is it. Um, sorry, yeah, that was for when you start it, just set the values to whatever the values actually are. So obviously, have to toggle on full screen if the game is on full screen. But then the player can change it, and then it's only when they click the apply button where it actually changes into the value. It's quite difficult for me to test if the VSync is actually working, uh, but I trust that it does because of this code. Um, but then, yeah, if we go, it's the same sort of principle with this inheriting interface data persistent, load data, save data. It doesn't need to save anything, so it just returns. Uh, and then if this is just it looks this long just because it displays it as a like 0. So if it's like 1 minute, it displays it as 0 1 and not just 1. So that's a nice thing about having it sort of separate, is you can have like the variable and the actual text box separate because you can sort of manipulate it like how you want it, like this. So yeah, open minute, open second, and then milli's the same. Milli's a bit so just round, so it doesn't have to display the whole float. And then the same thing for linear, and that's how it runs. So we see the enemy as follows a script, and the script was originally part of the engine, but it was very simple. So it was just basically attack player and kill enemy, but I made it a lot more. So it has a nav mesh agent, which is basically following, so that it has its AI, sort of. The AI in the sense that it does not, so it can set some values like its speed and acceleration. So you can set that for each individual enemy. So that's how I have it. So say these guys here are faster than the one that was on this platform. Because I did it manually. Yeah, you have to do it manually, but it can just make it more fair because this is like an open space. So these are it's sort of easier to see these guys coming and to avoid them or to attack them. And then say this guy he's on a smaller platform, so it's less room to work with. So I wanted him to be slower. So this sort of thing can allow me to manipulate each of the enemy's individual AI. But they also sort of the same script and the same structure. They can just have different variables here. And I set like the chase speed and um, their walking range, so like how much area they walk around, their sight range, so how far the player is before they're detected, and then change states. So if I actually showcase that code, um, so yeah, that's for that. Um, the layer mask is so that the enemy knows what is the ground, so that they stay on the ground, and also what is the player, so they can detect the player. If I skip through this, just go through to so yeah, update. Check um, player position, and if they are not in sight of range, uh, so if they're not in the player's range, then they're just patrolling, or otherwise they're chasing the player. So it's just two states that I have. So basically, if they're patrolling, they're if they don't have a walk point set, then they set the walk point. If they do have a walk point set, then that's their destination. Um, and then if we search, so if they don't have walk points, then search walk points. So we go to, so they just get a random point within their like range of what they're given, um, and it basically just sets it to that random position. And then if so, physics raycast. So basically, if what below that random point is ground, then walk point set to true. And the way how I made this work was I had to make a nav mesh. I forgot what it was called. Just nav mesh. And then basically, so it can detect all of this as ground. So it works. It's just one sort of game object that works for all enemies. So it's like this is ground or this is ground, and it makes sure so that it doesn't fall off. So say like because of that little bit marked for some reason is not marked as ground. Sometimes it does that. So these enemies will actually not go in this area, but it will go in anywhere that's marked blue. But it won't sort of say go off this ledge and then think that it can go down here because it checks only just below it. And if just below it is not ground, then it can't. Then it doesn't go there. So it sort of stays. It makes them stay in their position. So even though they're moving randomly within uh, like game logic that makes sense, or as in logic that makes sense that they stay on the ledge, and they don't fall off or they don't start like hanging around in the air or something like that. And it's the same for like there's enemies on there as well, and it's because of this, and also because of this is where they know how where the player is, because it's set as a point. But anyway, going back. Um, so yeah, then walk point set equals true, and then that's the destination, and then they go, and then basically, if they are within the range, which is here somewhere. Um, oh yeah, it's right in front of me. If distance, so basically, if distance to their destination is less than 1, then set it to false and just reset the position so they change direction. And their speed is, so their walking speed is always 1 when they're patrolling, but their chase speed is different depending on where they are. And then this set bool, I'll talk about the animator next, but I just want to go over the enemy AI. Um, so yeah, the chase state is quite simple actually. So it just sets the destination. So before the destination was set to the random walk point, but now it's just the player position, and then it just looks at player constantly, set speed to whatever the chase speed is set on the nav mesh agent. Uh, Set the animation so that it does the faster bouncing animation, and then that's it. That's the chase state. It just chases the player, and then it will go back to the patrolling state if it goes outside the sight range. Um, and then on trigger, this was code actually that already existed mostly. Uh, yeah. So yeah, last thing I want to talk about is just some how the animations work in Unity. So say for this prefab of the enemy, we go to, so every sorry yeah, so every animated game object has an animator attached to it, so you can see the animator, and it's, so if we can open that animator actually, and then the animator is essentially the like a sort of like a state machine actually. So the enemy is quite simple. So as soon as it enters, it just does the idle animation, which yeah, we can set idle, and then and then we play it, and it's just this simple. It was already, this animation already existed, but I did slow it down to sort of have it like this, and then uh, basically to transition to the move is player noticed equals true. So the player noticed that was set to the animator in the script is set to true whenever it's in a different state, and then that's how the animation changes. So then if we play the move, it's actually the exact same animation, but it's just faster. Um, and, and then yeah, and then obviously the transition goes back if it's false. So that's an example of a simple animation. Um, yeah, and then plays a slow one. But the most complicated animation was the player. So I will get that up quickly. Player character. Yeah. All right. So this I didn't actually set, so we'll ignore that. But so play entry and plays the idle animation. We need to select the, yeah. So it's just the idle animation that I chose to use. This one was not broken, but all the others were. So we go. So the player runs if their speed is greater than 1, um, which is in the player script that I set with the animator, and is ground, and if they're grounded, which is also set to the animator, which I might show off if I have enough time. But um, the so yeah, sorry. If we go to the run animation, so yes, for example, the original run animation was the player sort of, it didn't really look quite right. Like the if we play through it slowly, it the limbs just kept snapping at certain points. So I tried to fix it to the best of my. It still kind of actually looks like he's limping a bit, but it does look a lot better. And to be fair, when you're playing the game, you don't really notice it. Um, it looks like perfectly fine, to be honest. And the so that's just an example. The jump animation was also broken, but I did change it anyway because this was originally the character's rolling animation where they would do one somersault into like a roll and then come out of it. But I sort of made it that it just flips. And so if I go back to the player class, just to show off the animator, yep. So this is the sort of animator that's assigned to the player, and then so yeah, set grounded to grounded. Grounded was already a variable in the code for uh, to basically determine if the player can jump. This was already in the code, but then I managed to make use of that for the animator. So whenever they're grounded, set that to true for the animator. So the animator knows basically when the player should do their sort of flippy jump when they're not grounded. And I actually have the animator also in a different class from the engine, action regular. Um, the only reason I have it like this in two separate is because this was the only way I could get it to work. Because for some reason it just wouldn't work. But this was if it equals one, it equals 0. This was just to make it so the speed, if it equaled 1, it actually meant that it wasn't moving. And I set the animator so that the speed was 0. Otherwise, the speed was equal to the magnitude of the forward of new forward. So basically, the speed of the um, player, and just anything that's above 1 will mean that it plays the running animation, and then if it's equal to 1, it just equals to 1 because that's how the magnitude for this sort of worked. But if it equal 1, that meant that the player wasn't moving, so I set the speed to 0 on the animator. But then otherwise, it does that. And that's pretty much everything I wanted to showcase. It's not everything that I developed, but it's pretty much all the main things. So that I want to talk about, like I also developed the pickup, but that's quite a simple uh, function. And some of the things as well, like yeah, the death plane for the other level, where if you jump off the level or if you fall off the level, then you lose life. I developed all the AI, sorry, the state machine of the enemy as well, but the UI, user interface, except the font is reused, but um, and the data saving as well, I did, and yeah, all the Blender models, or a lot of the modeling of the levels I made, and yeah, that's pretty much the main things I wanted um to show off in the video. So thank you for watching and take care.